So here's a simple motor. I want to explain some of the parts that are in this. What I want to really focus on is this part right here, and that is the commutator. So of course we have our power source, we have the electrical wiring to create our circuit. This is the positive end. Again, this is where the electrons are going to be coming from, so the current's going to be running in this direction over here. Okay, so what I'm going to do is I'm going to start with the position right here. And what I want to point out is that we have a solenoid here and a solenoid over here as well. There's no power running through this. This is kind of spinning freely. But what I want to show is the direction that the solenoid is. We have to actually apply one of the other right-hand rules, and it's the second right-hand rule. So here's where the current's going to be coming from. It's going to be going through the wire. It's going to be attached to this. It's going to be running along this. And notice how it's going to be attached to this part right here. Again, this is the commutator, and this is actually going to be able to switch the direction of the current, and I'll show how that happens. So imagine that it's in this position. So first of all, let's see what type of temporary magnet will be created from this solenoid, which is, again, just a coil of wire. Well, if the current is running in this direction with the second right-hand rule, if you remember that your hand follows the current, and if it follows the current, your thumb is going to be pointing towards the north. That's going to create a north pole magnet here and a south pole magnet here. Okay, so when it's in this orientation, just like this, what's going to happen? Here's the south pole. It's going to be attracted towards the north pole. So it's going to get sucked in like this. Okay, so it's going to be sucking in like this. But then, again, this is the commutator. This is where the current is going to switch. Now that it reaches this point right here, what happens now is the current's going to be coming in this direction. It's no longer contacting this side of the commutator, but it's contacting the other side. Now the current's going to be running through this direction over here. But take a look at the direction. This actually goes underneath first. So following the second right-hand rule, what's going to happen is we follow it underneath and we curl it around, and we'll see that it's actually pointing in this direction. That creates a north pole here and a south pole here. What's going to happen with the south pole when it's aligned with the south pole? It wants to repel, and it wants to get that as far away from it as possible. Okay, now we reach this position right here. Okay, remember, this is the south pole, this is the north pole, south pole, and the south pole is going to be attracted now to the north pole over here. So we have the repulsion on this side, and then we have the attraction to this side. And then right at that point in time, it's going to switch. So now the current is running in this direction, and it's running to this side first. Okay, and this is going to be going on the underside. It's going to be creating, again, it's going under, it's going to be creating a north pole here and a south pole here. Okay, but then again, the south pole is going to be attracted towards the north when it gets repelled. So let's see if I can get some motion here to show you. So here, okay, it gets attracted. You can see that movement and that motion. And this just needs a little jump start. And then it runs continuously until you detach the current. And again, the current, what it's doing is it's running through the solenoids. It's creating these temporary magnets in here, and they're responding to these permanent magnets. And they'll either be attracted to or repelled from in the magnetic field.